Now we will learning about displacement. Okay, we will learn some more things about displacement. For example, there is this equation given: Fe plus Cu is a 4. But will it react or will it not? Okay, so let's remember that. Uh, Please stop calling me a zebra. Right? What was there? Please stop calling me a zebra. I like. Now here that iron is there. Okay, so iron, right? Iron is after, like before copper, right? Copper is after that. So the reactivity in the reactivity series, what we have, see that iron occupies a higher position. If it occupies a higher position, so we can conclude that it is more reactive. So it will react and it will react and it will do what? It will displace this copper and it will give Fe2 plus C. Okay, this will be the equation. Similarly, lead is more reactive than copper. So, right. So these kinds of things can occur, right? Now, another thing, you might be asked, uh, that now you will say Cu is a full plus Z. No, Cu is less reactive, so no change will be taking place. Whereas if the condition was otherwise, so that can give. Okay, so these were some examples of displacement reaction. Now, double displacement reaction. We have to learn about double displacement reaction. What is double displacement reaction? For example, ठीक है, there are 4 individuals. ये आप हैं, ये आपका एक दोस्त है, ये और एक इंडिविजुअल है, उसका एक दोस्त है. ठीक है. नाउ यू आर फॉर सम एग्जांपल. ठीक है, आप विराट कोहली का फैन है और ये रोहित शर्मा का फैन है. ओके. नाउ यू आर क्वारलिंग बिटवीन ईच अदर. ये नहीं विराट कोहली इज बेटर, अरे नहीं रोहित शर्मा इज बेटर. ओके, एंड द सेम थिंग इज गोइंग ऑन हियर आल्सो. ओके, ही इज सपोर्टिंग कोहली and he is supporting Sharma, right? Now you do one thing. Okay, you take this Kohli supporter. Okay, and you just displace your own friend with this Kohli lover. Okay, Virat Kohli supporter, and your friend who likes Rohit Sharma, he took away your friend who was also a Rohit Sharma fan, right? So here both are Kohli fans and here both are Sharma fans, right? So ऐसा ही कुछ होता है डबल डिस्प्लेसमेंट में. ओके, let us see how it happens. So डबल डिस्प्लेसमेंट, राइट? डबल डिस्प्लेसमेंट में ये जीएफ का मतलब जनरल फॉर्मूला होता है. ठीक है, ए बी प्लस सी डी गिव्स ए सी प्लस बी डी. ए सी को लेके भाग गया और बी डी को लेके भाग गया. ओके, सो there is double displacement going on, right? For example, okay, BaCl2 plus Na2SO4. BaCl2 plus Na2SO4. Okay, now this NaCl, okay, and this BaSO4, ये white precipitate form करेगा, whereas both these are colorless, right? Now the thing is that see, B, अब इसको लिखना कैसे है? इसके साथ इसको एंड इसके साथ इसको, ओके ये इसको लेके भाग जाएगा, ये इसको लेके भाग जाएगा, राइट. So this kinds of reactions, and this is an important reaction. You have to remember this: BaCl2 plus Na2SO4. Just you have to interchange the cation on anion. Cation is cathode was negative. Cation will be positive. Whereas anion is negative nature. Okay. So यहाँ पे SO4 2 minus इसको बोला जाता है anion. Okay. Cl minus anion. What are the cations? Na plus cation. Okay. ये BaCl2 Ba cation. Okay. So these are the things. Now let's see another thing. Another example of double displacement reaction. लीड नाइट्रेट के बारे में हमने पढ़ा हुआ था, PbNO3 2. Okay. Now this when combined with potassium iodide. Okay. This क्या होगा? PbI को लेके भाग जाएगा और PbI के साथ और ये NO3 के साथ, राइट. नाउ वी हैव टू बैलेंस इट आउट. PbI2 होता है, ओके सॉरी PbI2 होता है. ओके सो PbI2 अगर होगा I तो यहाँ पे right, it is balanced. Now the thing is that these are colorless, these two are colorless, but this PbI2, this is will give yellow precipitate. So the examiner might ask a compound X and compound Y, both are colorless and both are combined together, and compound A is released, precipitated, and the precipitate is yellow in color, and KNO3 is there. So what is compound X, Y, and A? Okay, you have to write it accordingly. Okay, now we will learn about one more thing, that is oxidation and reduction. Oxidation. The definition of oxidation is addition of oxygen or removal of hydrogen. Okay, active addition of oxygen or removal of hydrogen. For example, here oxidation of carbon is seen because this carbon is added with oxygen, so oxidation of carbon took place, right. Hydrogen sulfide, right. This is okay. Here oxidation of sulfur is seen. What is it? Oxidation of sulfur is seen here. Okay. Now the reverse is also reduction. So reduction is removal of oxygen or addition of hydrogen, right. Removal of oxygen or right, what you can say, addition of oxygen. Now here you see one thing, that oxidation of sulfur was seen, right, but here reduction is also taking place. What is being reduced? Bromine is getting reduced. So we can say hydrogen is added with the bromine, so reduction of bromine is seen here. Okay, like that. Into by this process ammonia is formed. Nitrogen is reduced because addition of hydrogen is taking place, right. There are many examples like that. Okay, ZNO plus C gives CO. Okay, let me write it for you. here, have you noticed one thing? If you are writing and you are writing, both are different. The upper one is for cobalt and the lower one is for carbon monoxide. Okay, keep it in mind. If you are writing the oxygen in lower case, then it will imply different meaning. It will have different meaning. Okay, so we should not make such mistakes, right? Now here the reduction of zinc is there. Okay, whereas here the carbon dioxide is getting carbon is getting oxidized. So here oxidation is also taking place. So it can be also known as redox reaction that we are going to learn. Okay, what are we going to learn? Redox reaction. What is redox reaction? Reduction and oxidation taking place. Taking place how? How? Simultaneously. Okay, in one reaction only, oxidation and reduction are taking place. Okay. For example, like what we have said, ZnO plus C gives Zn plus Co. The zinc was getting oxidized, was getting reduced, and the carbon was getting oxidized. Right. For example, you can say that something like, for example, right, A is getting reduced, whereas B is getting oxidized. Okay, right. So these can also be the thing, right? Now let us understand some more things about oxidating agent, okay, and reducing agent. So oxidation agent oxidizes, but itself it gets reduced. And reducing agent. Okay, oxidating agent or oxidation agent is also known as oxidant. The reducing agent is also known as reductant. Reduces. Okay, it reduces the elements. Okay, but itself it gets oxidized. Itself gets oxidized, right? Now, for example, copper. If you burn copper, okay, if you oxidize copper, oxidation means burning. Okay, so if you burn copper, this is, whereas this is black. Copper is shiny brown, right? So copper reacts with oxygen or is oxidized to give the oxide of copper, CuO, and that is black in color. Okay. Now, if we have to obtain this copper, what would we do? CuO, okay, and hydrogen gas is passed with it. So what will happen? Cu plus H2O. Again, same, shiny brown color, retained or regained, you can say, right? Now, some topics of NCRT's NCRT has been, I think so, deleted, but these are important. Let's learn about these things. Number one thing is corrosion. Corrosion means metals if attacked by by acid, moisture, or oxygen. Okay, so it decreases the lifespan of the metal. It decreases the durability of the metal. Okay, of the metal. Okay, the thing is that non-metals do not corrode. Only metals corrode. Okay, now this corrosion. Okay, for iron we call it rusting. Corrosion of iron is known as rusting. Corrosion of silver or silver ornaments is known as tarnishing or tarnished. Okay, rusting or rusted. This is tarnishing or tarnished, right? For example, I have a silver jewelry here. Okay, it looks so much dull, right? Why? You should not say it has like it has seen corrosion or corrosion is has occurred in its layers. No, you will say that this silver ornament has been tarnished. Okay, it has been tarnished, but it has it used to be very much shiny. Now it is blackish in color. Okay, right? Why is it blackish in color? Because a layer of oxide has been formed on its surface, so it is tarnished. It has lost its lustrous property. Luster means shine. Okay. Property of metals. Okay. So now we will see how this rusting and all occurs. We would first start with uh, iron. Okay. Now this oxide of iron, it is reddish brown in color. Okay. This is the equation of rusting for iron. If the examiner asks you, okay, to write the equation for rusting, please write this one. Fe plus O2 plus H2. So to rust, iron needs air and it also needs moisture. Both things should be present. If only air is present, no, it will not do its work. Okay, and if only moisture is present, it will not do its work. Now you may say that in air, like vapors are there, water vapors are there. Discarding that thing. Okay, if no air vapors are there or water is not present in the gaseous form. Okay, only air, pure air. Okay, oxygen, nitrogen, carbon dioxide. This okay is if present, then it will not corrode. Okay, it will not rust. Right. Or if you are giving in moisture. Okay, if you have submerged it in moisture. Okay, water, but there is no oxygen supply, it will not corrode. Or it will not rust. Now another thing is silver. How silver tarnishing is there. Sulfide, okay, that's present in our air. Okay, so this AgS, it is shiny, whereas this is dull, black also. Okay, right. This another thing is copper also gets corroded. Okay, this is carbonate of copper. This thing is known as carbonate of copper. Okay, CuCO3 dot CuOH2. Right. This is the reaction that is involved in the corrosion of copper. Okay. So this is the thing that we needed to learn. Now we need to learn one more thing, and then this topic will be over, and that is rancidity. If oil or fats is exposed in air, air has oxygen, so oxidation occurs. As a result, smell or odor or taste degrades, and this phenomenon is known as rancidity. How do we prevent this rancidity thing? आपने चिप्स खाया होगा, लेस खाया होगा, कुरकुरे खाया होगा, राइट? आपने देखा होगा, आप ये चीज़ को लेके कंप्लेन भी करते हैं कि अरे बहुत ज़्यादा हवा भर देता है। दैट इज़ नॉट हवा, दैट इज़ नाइट्रोजन गैस। तो ये नाइट्रोजन गैस से प्रिवेंट हो सकता है अगर आप नाइट्रोजन गैस से उसको सील कर देंगे तो। सेकंड, एडिंग एंटीऑक्सीडेंट्स। क्या बोला मैंने कि ऑक्सीडेशन हो रहा है, तो ऑक्सीडेशन का रिवर्स क्या है? एंटीऑक्सीडेशन। तो एंटीऑक्सीडेशन कौन कर सकता है? एंटीऑक्सीडेंट्स, राइट। एंटीऑक्सीडेंट्स जब तक रहेंगे तब तक ऑक्सीडेशन नहीं होगा। और थर्ड, रेफ्रिजरेशन। रेफ्रिजरेटर में आप उसको स्टोर कीजिए, फिर भी रेंसिडिटी से ये ऑयल और ये फैट्स वाला फूड ये बच जाएगा। इट विल नॉट डिग्रेड इन इट्स टेस्ट और इन इट्स स्मेल। ओके, सो दिस वाज द कंप्लीट चैप्टर। थैंक यू।